of your graphs should look like this. So in y1, you have x plus 5. And in y2, you have negative 2x plus 5. And you hit zoom 6. And you do not have 2 lines on your graph.
No, I have 1. I have 1 too.
Did you hit the X key under mode, or did you make sure you hit the negative and not the minus? Okay.
Oh, no, mine's the minus. I got it. Why did you hit alpha?
To center it so all our graphs were identical. No, just hit the button under mode, because if you do the alpha, it might not work. Like you literally just hit the XT theta. Like if you just hit that, it'll put an X.
So never mind, I found it. They literally just wasn't.
All right, so question 2. Do the graphs have any points in common? If so, how many?
1.
1. So that's the answer to 2A on your note guide. 2A, 1. Looking at the equations, compare the slopes. Are the slopes the same or different? Okay, wonderful. Part B, graph those two equations. So you have 3x plus 2 and 3x minus 1. Graphing those two functions. Answer to question 2. Do the graphs have any points in common? Do these two graphs have any points in? No. Why?
Because they're parallel.
Perfect. They're parallel lines. Parallel lines never intersect. Okay, number 2 for part C. Negative 4x minus 2. And then alpha y equals to get the fraction. Sorry, this mode's in the old font. If you go to alpha right here in green, and then you hit the y equals key and enter, it gives you a fraction. So then on top, you would type 8x plus 4, and on bottom, negative 2. Graph. There's the first line. There's the second line. So when I only see one line, what does that mean? It's the same line. So how many points do they have in common?
Every point.
All of them. What?
I still cannot make the
Alpha right here in green.
Yeah.
And then you hit y equals and enter.
Oh.
And did it give you a fraction?
Still not.
Let me check your calculator. You might be in the wrong setting. All right, so we talked about part A, we talked about in B and C in part 2, and then we compared their slopes in part 3. So the slopes of the lines in number 1 are different. The slopes of the lines in part B are the same. And here, if you simplify this fraction by dividing both parts, we see that the slopes once again are the same. So that leads us to what we're going to talk about today, which are 3 different types of lines. We have intersecting, parallel, and coinciding. Intersecting lines are 2 lines that meet at a single point. Parallel lines have no points in common, and coinciding lines have all points in common. Parallel lines and coinciding lines will have the same slope. Intersecting lines cannot have the same slope. And then the y-intercepts are varying depending on what equations we're talking about. So intersecting lines can have the same y-intercept, but they could also have different y-intercepts. Parallel lines are the only lines that cannot have the same y-intercept. And coinciding lines, much the same, must have the same y-intercept. So what we're going to do today is talk about graphs of systems of equations. So we have three different types of systems. We have intersecting, parallel, and coinciding. Is everybody okay for getting all that information down? So a system of equations is a set of equations that use the same variable. A system of equations is the set of equations that use the same variables. So linear systems of equations are in two variables, x and y. We also have systems of equations that are in three variables because we have three-dimensional systems, and those variables are commonly x, y, and z, or a, b, and c. So what we're mainly going to focus on are linear systems. Linear systems are systems of equations that have lines for graphs. So that's why a lot of your review had to deal with lines and inequalities. The solution of a system of equations is the intersection of the graphs. The solution is the intersection of the graphs. So if the graphs don't intersect, then we have no solution, which would be parallel lines. We define systems in one of three ways. A system is independent, dependent, or inconsistent. An independent system has one solution. So if you think about being independent, you're kind of like on your own. You're an individual. So independent has one solution. Dependent, so you are dependent of your parents. You depend on them. So dependent has many solutions, or as a dependent, you depend on many other people. And inconsistent has no solutions. We can see each of these graphed out, much like we did in the warm-up. So in the warm-up, we had example A that was intersecting, example B was parallel, and example 3 were coinciding. And what we saw from that warm-up example is that independent lines intersect with one solution. Coinciding lines are dependent with no solution or no unique solution, which means if they don't have a unique solution, that they have rather infinitely many. So no unique solution is a way of saying infinitely many solutions. So again, no unique is a fancy way of saying infinitely many. Okay, so in that next set of examples, it's frozen like up on there, but not down here. All right, for this next set of examples, we're going to classify the system without graphing. So what that means is we are going to compare each of these by looking at simply their equations. So what I want to do is look at the equations. Okay. So to classify without graphing, what we're going to do is rearrange both equations so that they are in y equals mx plus b form. So we want to get both equations into y equals mx plus b form so we can compare m and b. Because if the m is the same, then they're parallel. If the m and the b are both the same, then they're coinciding. And if the m and the is different, then they're intersecting. And that will help us classify. So we classify the systems in 3 ways: by their name, by the number of solutions, and what type of lines we have. So this is y equals 3x plus 2. Solving this equation for y, you get 2y equals 6x plus 4. Dividing everything by 2, you get y equals 3x plus 2. So when we simplify the second equation, we see that it's identical to the first equation. Therefore, these are coinciding lines. Coinciding lines have infinitely many solutions. And they are considered to be a dependent system. So all graphs or equations of systems will be classified in 3 ways: the types of lines, the number of solutions, and the type of system. Solving for y, you get y equals negative 3x plus 5. Over here, we get 5y equals negative 15x plus 2. Or y equals negative 3x plus 2/5. So what you'll notice is that the slopes are the same, but the y-intercepts are different. So same slope, different y-intercept makes them parallel lines. Parallel lines have no solution, and they are inconsistent. Okay, and number 3, the first one's in y equals mx plus b. So we'll add 4x to the second equation, divide everything by 2. And again, we see that these are the same. So I have coinciding, infinitely many, and dependent. Yep. Yeah. And then in example 4, we're just going to solve for y once again. So you have negative y equals negative x plus 5, or y equals x minus 5. And here you get y equals 2x minus 3. So once again, we see that we have 2 lines. The slopes in this case are different, so therefore they are intersecting. one solution, and independent. So much like all new chapters, the first lesson is usually pretty easy. I feel like this lesson is pretty much vocab. The idea behind this is that you need to be able to know and understand what these words mean because we are going to start solving these systems. And if I say, oh, hey, they're parallel lines, you need to know that means there's no solution to that system. So for homework tonight, you're doing the front and the back of the next page in that packet. The front are graphs. The back are equations. Once again, you need to classify them in all three ways. So tell me, are they inconsistent, dependent, or independent? Are they of one, none, or many? And are they parallel, intersecting, or coinciding? It's not a trick. Some of the graphs only have one line because they are coinciding.